and welcome to this video where we are going to talk about the distance formula and being able to find the distance of line segments on the coordinate plane. So we're going to look at a couple segments that are pretty straightforward, and then I'm going to show you, what happens if it's not a straight line segment. How do we find the distance in that case? And then we're going to talk about what this distance formula looks like, and then when we're in class, we'll apply the distance formula. So, here the first two segments, to find the distance is pretty easy. You just have to count the block. So the distance of CD here, this segment CD, we just have to count how many blocks there are from D to C. So you have 1, 2, 3, 4, 5, 6, 7, 8, and then it looks like we're at a half here, so our distance is 8.5 units. Now the way we write this, CD, notice we don't have the segment notation above. We write it just as the two endpoints, and that's how we denote length in geometry. Likewise, the length of segment AB, again, we just have to count the spaces. So 1, 2, 3, 4, 5, 6, 7, 8. So we have a distance here of 8 units. AB is equal to 8 units. So that's not too bad, pretty straightforward. It's pretty simple. Well, what if we don't have straight line distance? Okay, so you look here in this next example with segment AB. How in the world are we going to find the distance in this scenario when we can't count blocks? Well, there was probably a reason why we talked about the Pythagorean theorem before we got to the distance formula. And the reason for that is any line segment has a slope. And if you remember from Algebra 1, you're able to draw in the slope triangle on any line segment. And when I do this slope triangle, we end up with a right angle here where the vertical and horizontal components meet. Now this vertical distance is 1, 2, 3, 4, 5, 6 units. And the horizontal distance is 1, 2, 3, 4, 5, 6, 7, 8. What we're looking for is the distance from A to B. And if you notice, the slope triangle forms a right triangle, where the distance is just the hypotenuse of that right triangle. So to find the length of segment AB, it's just an application of the Pythagorean theorem, where x squared, the hypotenuse, will go by itself in the equation, and x squared is equal to 6 squared plus 8 squared. And 6 squared is 36. 8 squared is 64. X squared is equal to 100, as 36 plus 64 is 100. And then we take the square root of both sides. And x is equal to 10, which means that the distance from point A to point B is 10 units long. So the distance formula is just an application of the Pythagorean theorem. That's why we spent the time going over the Pythagorean theorem before talking about distance. So anytime we're given 2 points, we plot them, we can make this right triangle using the slope formula and then use the Pythagorean theorem to find distance. Now, there will be times where we're going to have to use the formula, the distance formula. So on the next page here, I'm going to walk you through the process of deriving what the distance formula is. So if we have a generic or a line segment with generic endpoints where the A is at x1, y1, and B is at x2, y2. If I make my slope triangle like so, we create our right triangle, and we're looking for this distance from A to B, which is D. Okay, so now we have to remember from Algebra 1 a couple things about slope. So if you recall, slope, which I'm going to write up here in the top left, is rise over run. Rise being our vertical piece, so the rise will be the vertical piece that starts at B and drops down to the 90-degree angle. The run is the horizontal piece that starts at point A and runs over to the right, to that right triangle, or right angle, excuse me. So if we're gonna find the distance from A to B, it's still an application of the Pythagorean theorem where the distance squared is going to equal whatever the run, whatever that horizontal component is squared, so the run squared plus the rise squared. Okay, which is great. But how do we put it in terms of x and y? So I'm going to go back up top here to slope. If you recall from Algebra 2, the slope formula, or how you subtracted your y value, so it was y2 minus y1 in the numerator. Well, that's what the rise is. The rise is just the difference in the y coordinates. So it's just y2 minus y1. So that means in this distance formula, I can replace the rise with y2 minus y1 squared. Likewise, the run, which would be the denominator of our slope formula, the run is x2 minus x1. So in this distance formula, I can replace run squared with x2 minus x1 squared. And that is equal to distance squared. All right, so now we're solving for distance, right? And we can never have negative distance, so it's only positive distance. So to get distance squared by itself, we can take the square root of both sides, and the distance formula, d, is just equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And this right here is the distance formula. So we have used both our slope formula and the Pythagorean theorem together to derive the distance formula. And when we meet next in class, we will use both. We're going to use Pythagorean theorem to help find distance, and then you'll find that there are some problems where we need to use this distance formula, and it'll help us to solve the problem. So that's all we have for this video. Thanks for tuning in, and I hope you're looking forward to the next time we meet in class to apply this distance formula. So long, everybody.